Hello viewers, welcome to Codifus. Uh, Welcome back to this yet another video. We are meeting after quite a bit of a long time on this YouTube channel. Today we are going to talk about Python code, which is a physics-based AI model which can be written from with the help of scikit-learn library. This is a simulation model, ML simulation model, which can create values and predict the gravitational force on a particular area, which is like a kind of a test simulator, one of the most basic versions which I have created with my own knowledge and also improved it with AI. So in this video we are going to deeply discuss about each line of the code. The source code will be found in my official GitHub repository, Python for physics calculations, which I have mentioned and given the link in the description box as well as the first comment. First of all, at the first line we are importing NumPy, pandas, matplotlib for plotting graphs. Here we are using importing number, which is an JIT compiler, just-in-time compiler, which can improve the clock speed, which can improve the programming speed of a program, but it is quite limited to some of the programs. We will deeply discuss about number in an exclusive video in the coming weeks. We are importing pint for unit conversion, like converting the values from kilometer to meter or something centimeter to meter and some kind of conversions. For machine learning we are importing sklearn, from scikit-learn, linear model called linear regression, which is a linear machine learning model, and also we are importing R2 as metric parameters. Here we are just registering, calling units. We are initially setting up the unit system here at u register is equal to unit registry of, and q underscore is equal to unit registry of quantity, how much quantity. This set of code basically meant about the unit engine, setting up the unit registry, which is a global variables. Here we are registering. For here we are using at njit, we are calling number, which is in JIT compiler here for increase the computational speed. JLD compiled code here. Our function is gravity code, m1 m2 r in meters. Gravitational value, the standard gravitational constant value here. This is a formula to calculate, and we are declaring a class called formulon. This is our initiate function. We are using name called master engine here. Self.name is equal to name. The g standard value is equal to, we are giving the standard gravitational constant value. Pass unit, we are using this kind of thing to convert those units to another stuff. We are currently using pint here. For calculations we are doing the calculations here from JIT compiled calculations for the gravity, to find the gravity, and afterwards we are using machine learning tools to analyze the data patterns which we are providing here. Print f is equal to self.name, analyzing the real data. The unit conversion we are applying here, we are using a lambda function here. You can see pass unit we are using for the unit conversion of the data which we are using here. We create excess the product of masses divided by the r squared, which is obviously the formula itself we are explained here. We are using x and y for the plotting purposes of the graph. The model is equal to linear regression of, we are currently doing the machine learning stuff here. We can see discovered value using the model which we here are given, like we are predicting what values will come up next. And this is the plot area. We are going to plot, we are setting the plot style, figure, the scattering, like the graph. I will share the output graph in my GitHub repository, you can see how does the uh, program plots the graph and how does it predicts the values. So these stuffs are plt dot all or for matplotlib for graphical representation, or in range linear space, and these subs for we are using numpy for ml smooth ml prediction, and these all are also the plotting stuff, the graph plotting stuff. And we have the example execution here. This is an example part. Here we are seeing like engine is equal to formula on astrophysics model, and we are going to find out the earth moon force. Here we are giving the data, just about real world data, and we are adding noise because predicting something which doesn't mean it will come as a linear thing. In physics we are dealing with non-linearity, so we are adding noise to this code. We are appending clean of mp random, like we are giving a 5% noise here, like maybe 0 to 5% of ups and downs will happen in the real world data. It will form the data, g found, accuracy results, all our things will come under this stuff, like analyze patterns, which is the stuff we have already written here. And finally it will print out the values, and it will plot the values as well. Well, this is a code which I have written with the help of AI, obviously, but it is just for beginners to learn how you can use computational machine learning to find and simulate the real world data with the theoretical ones. This is one of the breakthroughs way to compute data. In future, as a creator of the Formulon physics library, Python library, I will upload more and more videos about my library itself, and we are going to integrate machine learning tools into our Python library, so students and other people can easily do mathematical, physical, as well as other kind of calculations easily and thoroughly. Thank you. See you in another video.